All right, second day of our solving and graphing compound inequalities. So let's first of all just review what we talked about with the and inequalities. So basically, like all equations and inequalities, our goal is to get the variable by itself. So this is going to happen in two steps. The first step is we need to get rid of this 6. So this is a positive 6, so we're going to do the opposite and subtract 6. But again, we don't want to do it just once or twice. We have to do it to all three places. So left, middle, right. All of them need to be subtracted by 6. So 6 minus 6 is 0. On the left-hand side, I have 21 minus 6, which will give me 15. And on the right-hand side, negative 19 minus 6 will give me a negative 25. And the last thing that we need to do here is get rid of this negative 5. Now this is being multiplied by x, so we're going to do the opposite and divide. So we're going to divide all three pieces by negative 5. Now we just divided by a negative, so again, we're going to just make a little note here, put some stars or something, just to indicate that we realize something has happened here that requires us to flip those inequalities. All right, so this is going to be 15 divided by negative 5 is negative 3. This will now become a less than or equal to x. Negative 5 divided by negative 5 is 1, so there's a 1 there. And we flip this greater than to a less than. Negative 25 divided by negative 5 is 5. So then the way that we graph this is put the smaller number on the left. This is less than or equal to, so that is a filled in circle. Bigger number on the right, that's a 5. This is just a less than, so that's an open circle. And then an and inequality we shade in between. So what we are adding in today is the or inequalities. Okay, so compound inequalities joined by or is any number that will make just one of the inequalities true. Because what we're going to end up with is something that looks like this, like x is less than negative 2 or x is greater than 5, something like that. So the word or here is important because there is no number that is both in this set of numbers, all the numbers less than negative 2, and this set of numbers. Like you can't give me a number that is both smaller than negative 2 and greater than positive 5. So that's why it's connected with or. It's either in this set over here or it's in this set. Okay, so it's important there that we know what's happening. Now, the one piece of information that I can give you here that is very, very important is when you do these, graph the inequalities separately. Okay, and there's a reason for this, and I'll show you in one of the problems here why we're going to graph them separately. Okay, so let's just go ahead and jump into these examples. So first one up here, now what I'm going to do is we're going to do these separately. So or is the word that's combining these to make them a compound inequality. But when we go through and solve these, we'll do them individually. So I'm going to do this whole thing individually, separately, solving and graphing. And then I'm going to come over here and do this one and solve and graph this one. So let's go ahead and get started. I have a negative 2 that needs to be moved. So I do the opposite and add 2. The whole process here is not any different than anything that we've done with solving or graphing equations or inequalities. All right, so it's all the same process. It's just the way our graph looks at the end that's different. Negative 2 plus 2 is 0, so my whole left-hand side is 4y. Is greater than or equal to 14 plus 2 is 16. And then my last step here is I will divide both sides by 4. 4 divided by 4 is 1. So I have 1y is greater than or equal to 16 divided by 4 is 4. So let me come over here to the second one and solve this one, and then we'll graph them both separately. So first up, move this 4. So I'm going to add 4 to both sides. Add 4 to both sides. Negative 4 plus 4 is 0. So my left-hand side is 3y is less than or equal to. Negative 13 plus 4 gives me a negative 9. Last step over here, I need to divide both sides by 3, and I get y is less than or equal to negative 9 divided by 3 is negative 3. So there's both of them being solved. Now I'm going to graph these. Let me bring my number line up here so we can put these all on the same page. All right, now, if I'm graphing these, I'm going to do them in the colors that I solved the problem in. Again, I'm going to put the bigger number on the right, so that's 4, and the smaller number on the left, that's a negative 3. I'm not going to worry about putting numbers in between. So let's graph y is greater than or equal to 4. So here's 4. Greater than or equal to means shade in the circle, and greater than means shade to the right. Y is less than or equal to negative 3 means at negative 3 I put a filled in circle, and less than means shaded to the left. All right, so in most of your OR inequalities, you see something that looks like this. All right, you got your two circles, and the shading happens outside of those circles. And inequalities are always the two circles and shaded in between, always. But the OR inequalities, most of the time, it will look like this. Okay, your two circles and then shaded outside of the circles. But that's not always the case, and that's why I tell you to graph these inequalities separately, because in the times where that doesn't work, you will still get the problem correct by doing it the way that I'm showing you here, just by graphing them individually. So let's go ahead and do this next problem. Start off the same way. Again, I'm just going to put my divider here. So start off over here on the left-hand side, get rid of that negative 4, so I need to add 4 to both sides. Negative 4 plus 4 is 0. Those are gone. Left-hand side is just a 5a. Is greater than 16 plus 4 is 20. And then I divide both sides by 5 to get a by itself. So divide by 5, and 5 divided by 5 is 1, so I have 1a is greater than. 20 divided by 5 is 4. Other inequality. I need to get rid of the 2 first, so that requires me to subtract 2. I want that to be a 0, so 2 minus 2 is 0. Now I'm left with 3a. Still working towards my goal of getting this to 1a. I'm almost there. Last step I need to do here is divide both sides by 3. And I'm left with a is less than 5. Okay, so this is one of the other cases where our inequalities are graphed and they look a little bit different than the way it did in that last problem. So we're still going to start this the same way though. We put our smaller number on the left, 4. We put our bigger number on the right, 5, which they are consecutive numbers, so there are no numbers in between other than our decimals and fractions and stuff. And then we graph them separately. So a is greater than 4 means that open circle at 4, and we shade to the right. A is less than 5 means open circle at 5, and we shade everything to the left. So what this actually means is that we've covered the entire number line. So this answer would really be all real numbers. Any number that you choose would fit this inequality or this inequality. Okay, so that's another way that your answers could be graphed. So we could have something that looks like this with our 2 dots and shaded outside. We could have something like this with our 2 dots and not shaded in between, but there's actually an overlap that happens here because that 5 doesn't stop at 4, it keeps going to the left. It's all the numbers less than 5. The 4 doesn't stop at the 5, it keeps going to the right. It's all the numbers greater than 4. So that's another type. And example C is the third type that we will see. So again, what I want you to do is pause this and make sure that you can solve these inequalities. I'll do the graphing part with you, but go ahead and pause the video and solve them and see if you can get what I have. Okay, so 4v plus 3 is less than negative 5. First thing we need to do is get rid of this negative 3. I'm sorry, get rid of the 3, and we're going to do that by subtracting both sides by 3. So subtract 3 on both sides. Okay, 3 minus 3 gives us 0, so these are gone. So my left-hand side is just 4v, and then my right-hand side is negative 8. So I have 4v is less than negative 8. My next step is to get rid of the 4, so I need to do that by dividing. So I will, divide both sides by 4. 4 divided by 4 is 1. Negative 8 divided by 4 is negative 2. We do not flip the sign because the number we divided is a positive. Okay, if this 4 was negative, then we would flip the sign, but that's not the case here. So your answer there, v is less than negative 2. All right, now for the other inequality, let's run through this one. What's the first thing we need to do? Get rid of the 7. This is a positive 7. We do the opposite and subtract 7. Okay, so again, 7 minus 7 is 0, so those cancel out. 1 minus 7 is negative 6. So the left-hand side is a negative 2. Negative 2v is greater than negative 6. And now my last step is to divide by a negative 2. Okay, so divide both sides by negative 2. And this is now a problem where we have to flip the inequality because we just divided by a negative. So whatever you've been doing to just note that something is going on here, we flip the sign, so we don't want to forget about that. So negative 2 divided by negative 2 is 1, so 1v. I flip the sign to be a less than. Negative 6 divided by negative 2 is 3. All right, so now how does this look on our number line? Let's see. Started off the same way, smaller number on the left. So I'm putting my negative 2 over here. Negative 2. Bigger number on the right. That means positive 3 goes right here. And now let's graph them individually. V is less than negative 2. Well, just less than means open circle and shaded to the left. V is less than 3 means open circle at 3 and shaded to the left. And again, we don't stop at 2, keep it going. So really, the answer to this would be V is less than 3 because all of these numbers here are included in this set. So all of the numbers less than 3 would be your answer for this one, and you want to graph it like that. Now, you don't need to really worry a whole lot about that because problems like this one and example B do not show up very often. I know they're in half of my notes here because I wanted to make sure you saw all the options. But as far as like your worksheets and your quiz and the keystones, it's not really something that you see very often, if at all. So, but I did want to show you them because they are possible. All right, last example, and again, go ahead, pause the video, write down the problem, and go ahead and go through it and see if you can get the answer that I have. All right, so hopefully you did that, and let's see what you get. So first of all, move the 7. This is a positive 7, so I need to do the opposite and subtract 7. All right, so we're going to go ahead and cross those out. 7 minus 7 is 0, so those are gone. My left-hand side is negative 2. X is greater than 3 minus 7 is negative 4. So just like in that last example, I am dividing by a negative number. Okay, when you divide by a negative number, we got to flip the inequality, okay? So something's going to happen here. All right, so negative 2 divided by negative 2 is 1. Negative 4 divided by negative 2 is 2. So I have 1x, flip the sign to be a is less than symbol, 2. All right, other inequality. Let's see what we get on the other side over here. So first of all, we're going to add 4 to both sides. So add 4. 4 minus 4, I'm sorry, negative 4 plus 4 is 0, so these are gone. My left-hand side is just a 3x is greater than or equal to 5 plus 4 is 9. Last step, we got to get rid of this 3 and make it a 1x, so that means dividing by 3. 3 divided by 3 is 1, so we have 1x, that's what we wanted. And 9 divided by 3 is 3. So here we go, x is greater than or equal to 3. All right, that is the solving part. Now let's do the graphing part. Like always, smaller number on the left, so that's a 2. Bigger number on the right, that is a 3. For x is less than 2, I'm going to put an open circle at 2 and shade to the left. Other one, for x is greater than or equal to 3, I'm going to take at 3 and put a solid filled in circle. Greater than means shaded to the right. Okay, so again, like I said, these are the problems that you'll see most often, where you have the dots and shaded outside. But to avoid making that mistake, graph them individually. Like I said, do this one first and then this one. And just make sure that you have your numbers placed correctly on your number line and you should be good. All right, so like always, if you have any questions, send me an email, send me a private comment or something, and just let me know what your question is and I will get back to you.